All right. Well, thanks everybody for coming to our presentation here tonight. My name's Gary. I'm V6GDS, and my presentation partner here tonight is Ian Drummond, V6IXD. And we're pleased to be presenting on our experience with the Moxon antenna, and specifically, we'll get on to the triad. So just a quick outline here, what we'll do tonight. Just going to talk a little bit about intentions for the presentation, and then we'll do some background theory about the antenna. Ian's going to talk about field experience with the Moxon and best of all, how to actually build one. And we'll wrap up with a discussion of our project here, the Moxon triad. So our intentions here tonight to introduce the antenna, and we're going to concentrate on VHF and VHF and UHF applications for it. This antenna can be used on HF as well. We're going to show what we built and share some of our experiences experimenting with this antenna. But I will clarify a couple of things. We're not doing a magic bullet reveal here tonight, as I'm sure I look around, I see most of the rest are fairly experienced hams. So we all know that there is no magic solution to these things, and a Moxon is certainly not a solution to all of your antenna needs. There are trade-offs, and we'll talk about some of those. I also want to avoid getting into kind of a bake-off or a competition. I'll compare the Moxon to a couple of other antennas just to give people some context, but I don't want to get into a line-by-line competition of which antenna is the best. That's not really what we're here for tonight. We really want to focus on the Moxon and applications for this antenna. It has some very interesting properties that make it quite useful in certain circumstances. Some of our sources here tonight, probably one of the best sources for anything to do with amateur radio antennas is LB-CBIC W4RNL. It's a silent key now, but if you're not familiar with CBIC's material, as a ham radio operator, you're missing out. You really want to Google this guy's material. It's available on a couple of different web pages now. And the guy was an absolute magician when it came to antennas and antenna theory. So yeah, you want to have a look at his stuff. He did write a number of articles on Moxons, and we've used that to help guide our work. KD6WD has an interesting web page, the Moxon Antenna Project. There's dozens of articles there people have submitted about how to build and use Moxons. Great resource there. The Moxon Beam DK70 Bravo, really nice introductory article, very short. So if you're interested in Moxon antennas, there's a good introductory article there. And of course, you can't forget Les Moxon, the guy that started it all. The original article appears in his book, HF Antennas for All Locations. So what is a Moxon antenna? It is a rectangular two-element parasitic beam. So it's a directional antenna. It's a derivative of the VK2ABQ square, which was originally pioneered by Fred Canton. Now, you will see a lot of silent keys referenced here. That's not because of the Moxon antenna. It's not a dangerous antenna. It just means there's quite a few years of development that's gone into these. These antennas have been around for a number of years, and there's been a lot of work on them. So the Moxon is a fairly compact antenna. It's just around 2/3 the size of a typical two-element Yagi. And one of the ways you achieve that size reduction is the radiator and reflector elements are bent towards each other. So we'll just have a look at that. This is a diagram of what a Moxon looks like and the different dimensions of it. This is taken from one of CBIC's articles. So you can see there's a driven element with like two sides. You hook the one side of the coax to one side and the other side of the coax to the other side. And then there's a reflector. And these two elements are bent 90 degrees towards each other. But look carefully here, this C dimension is a gap. So while this antenna might look like a loop, it is not a loop antenna. It is closer to a Yagi, which is, of course, derived from a dipole. But it is not a loop antenna, despite the fact it may look like one. few of the characteristics of a Moxon. It has good forward gain. Now, I'm not going to say great, but good forward gain. It's just a small antenna. CBIC's 2-meter design cites around 6 dBi gain. Is there, I'm just going to ask a general question. Is there anyone who's not familiar with terms like dBi and dBd in terms of antenna gain? Should we talk a little bit about that? dBi is gain over an isotropic source, so that's like a star that radiates energy in all directions. Most antennas don't do that these days. So yeah, about 6 dBi over an isotropic, 6 dB over an isotropic source. And this is about a half dB less forward gain than a full-size 2-element beam. So you give up a little bit of forward gain, not a ton. That's a small amount. In fact, one of CBIC's articles says only about 0.2 dB. But what do you get in exchange for giving that up? Probably the number one thing you get is a really outstanding front-to-back ratio. I'm going to talk more about this in another slide. But the front-to-back ratio on this antenna is really quite outstanding. CBIC sites are around 18 to 35 dB front-to-back ratio on this antenna. So that means you're going to be getting a lot more power off the front of the antenna than off of the rear. And you'd have to build something quite elaborate to get that kind of a front-to-back ratio if you didn't want to use a Moxon. It also has very good bandwidth with a relatively flat SWR curve. It has a nice 50 ohm impedance, and that impedance stays nice and consistent all the way across a 2-meter band. In fact, there are articles on 10-meter Moxons, and the impedance just stays nice and steady all the way across the band. So you don't need fancy impedance matching, which can, of course, get quite lossy. Just a quick aside, we're talking a fair bit about dB here, so I'll just take 2 seconds and just to jog everybody's memory. I find dB always messes with my head, so I got to go back and look at the reference charts and remember what the numbers mean. It is a logarithmic scale, and so yeah, not linear at all. So 3 dB is around 2 times the power. If you're looking at 2 different levels of power and you're making a ratio against them, 3 dB references about twice the power. So 6 dB is around 4 times the power. So remember, we were saying the gain on this antenna, the forward gain on this antenna is usually around 6 dB. So that's 4 times better than what you'd get off of an isotropic source. The next 3 numbers, I'm going to ask you to keep these in your head for a couple of minutes here because we're going to look at these. 10 dB is 10 times the power. That's easy to remember. 20 dB is 100, and 30 dB is 1,000 times the power. And you'll see where this comes up. I'm not sure if everybody's familiar with these kinds of diagrams. It's an RF pattern diagram taken from one of CBIC's articles where he writes about the 2-meter Moxon. And what it is, it's a graph, and the farther out from the center, the more of the RF power you would receive if you were physically walking around the antenna and checking your receive power off of the antenna. So if you imagine the antenna right at the middle, the maximum power off the antenna is going to be in front of it, out here towards the right.
Are we looking at the top, of the antenna or elevation view?
Think of it as though you were above the antenna and looking down onto it. So like on like from a drone looking down on top of it. Imagine that the antenna is right in the middle here. You can see these dotted concentric circles. Imagine the antenna is right here in the middle. Can you guys see my mouse pointer? Is it showing up?
Yes.
Okay, good. So yeah, imagine the antenna is right here in the middle of this. And then these other lines are basically graph lines. And the farther from the center they are, the more power that you would receive, like in a receiver, if you were standing, walking around the antenna and standing at that point. So if you're standing right in front of the antenna is pointed here towards the right. If you're standing out here with your receiver, this is where you'd get maximum power off of the antenna. And then if you're walking around on the ground, you'd notice it slowly goes down, 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 and then it drops off fairly quickly when you're kind of at a right angle to the direction the antenna is pointing. You'd come around to the back and you'd maybe pick up a little bit again. And then, of course, that process, just goes inverse as you walk around to the front of the antenna again. Now, what CBIC has done here, sorry, go ahead.
I don't know if I can ask questions.
Yeah, go ahead.
The antenna that you showed earlier, is it vertical or is it like horizontal?
Oh,
Or
good.
does it matter?
Excellent question. This antenna will work in either orientation. So you can use either horizontal or vertical, and you'll get roughly the same results. This one here, he doesn't mention it on here. This may be a horizontal polarization here, but I'd have to go back and look at the article again to know for sure. But it doesn't change. This pattern doesn't change very much from horizontal to vertical with a Moxon antenna. So one of the things to note here, you go back to this dB. Now this is scaled. The software scales this. So it makes 0 dB the maximum power. This outer line here says 0 dB. 0 is not 0 watts. That's not 0 energy. That's 0 dB. Again, that's that logarithmic scale. That's powers working there. So 0 is actually the maximum. And then everything else is referenced with a negative number, negative exponents or fractions. So you're getting a fraction of the power, fraction of the power level. So this is really interesting with these antennas. If you look at the rear of the antenna here, all of these graph lines are inside the -20 mark. Remember what -20 is? That's 100 times less. So behind the antenna, you're getting 100 times less effective radiated power, if you will, than you would off the front of the antenna. And some of these lines go down underneath the -30, which is 1,000 times less. So this really shallow rear lobe is part of the advantage of the Moxon. And we'll talk more about that here in a few minutes. Now, one of the other things CBIC has done here, he's overlaid 3 different lines. One of them is at 144 megahertz, one at 146, and one at 148. So all the way across the 2-meter band, this front lobe is pretty stable. Okay, you're going to get about the same energy coming off the front. It varies a little bit on the back here, but they're all well under that -20 mark. So there's really not very much energy coming off the back of this antenna. And of course, if you're receiving, you get the same kind of thing. You're going to get maximum sensitivity in the direction the antenna is pointing, and you're not going to get much signal off of the back end of the antenna. And that's intentional, and that's actually an advantage. Any other questions on these diagrams? If you're not familiar with them, sometimes they're a little surprising at first. And anything else I can answer on this diagram?
Can you infer some kind of a distance relative to the strength of the signal on the 30 dB there?
So when you say distance, you mean distance you'd receive the signal?
Yeah, like you're indicating that, on the exterior lobe, that's where the strength is the greatest. Yeah, over there. So I can see, like on the chart, there's no distance scale on there.
Oh, no, it's this is all done with math. This is all from a program called EasyNet. It was something that CBIC used a lot when he's designing antennas. So this is all done with math, and this is the design properties of the antenna. So in terms of distance, we've been out testing this thing out in the field, and you have to get a few hundred meters away to get away from what they call the near field of the antenna. If you're too close to the antenna, yeah, it's hard to tell this stuff because your little device is just going to get tons of energy and it's going to overpower everything. Really, what you're talking about here would depend on how much power you're using. If you're using 10 milliwatts, I don't know, you might not be able to walk all that far from the antenna before you'd start to lose the signal. But you'd be able to go much farther away from it on this side and still get the signal than you would behind the antenna. Does that make sense? Am I answering your question?
Yeah, I think so. It's relative reference then.
Yes,
Okay.
exactly. So you can use these antennas for HF. People use them for 10 meters. You can build them for 20 meters if you want. And it is a beam antenna. That is essentially what it is. And so, yeah, if you want to put 100 watts into the thing on 20 meters and point it off into the horizon, you can work the world with one of these things. No sweat. We're using them mostly, again, for VHF and UHF at this time. So I'll do a quick comparison. This is a radiation pattern for a full-size 2-element Yagi. Now, I couldn't find one for the 2-meter band. I couldn't find a diagram for the 2-meter band in any of CBIC's material, but I did find one for the 10-meter band, and the patterns would be essentially the same, not dramatically different. So you can see on a full-size Yagi, this frontal lobe here, this front lobe is a little bit narrower. It drops off more quickly. The Moxon has a very, very fat front lobe. The other thing you notice is this rear lobe, and you have to look carefully, and I realize the diagram may be a little fuzzy, so I'll clarify. This dotted line here, sorry guys. There we go. This dotted line here is the 10 dB line. So the graph on the rear of a full-size 2-element Yagi, you're getting roughly 10 times less power from the back of the antenna than up to the front. Okay, so you got a front-back ratio. It's roughly 10 times more energy off the front of the antenna than off the back. So remember the Moxon, these lines are all under the minus 20 line, which is hundreds of times. So you get a 10-fold improvement in terms of that front to back ratio, which means that off the back of a Moxon, they're very, very quiet. You're not going to receive very much from the back of a Moxon, and that's actually an advantage.
Just a comment.
Sure.
Point of reference is that at what it was, I almost forgot. 1 S unit is 6 dB. So you can sort of relate it to S units as well.
Yeah. If your radio is well adjusted. So sure, let's take a look at this SWR curve. Now, I keep saying flat, and I know that line doesn't look very flat, but look at the scale here on the left. All the way across the 2-meter band from 144 to 148 megahertz. It's all within, 0.1 down here. Let's say it's about 0.1. And this is 1.3, 1.4. So that's pretty flat to get all the way across a band with the SWR, all in that smaller range. Some SWR meters that I've used, you'd barely be able to tell that much difference in the standing wave ratio off the antenna. So you get this really nice bandwidth with these antennas, and it's pretty consistent. For a small antenna, this is really outstanding. Quite often with small antennas, they have very, very sharp SWR curves. And even if you can get the SWR down low at your design point, you'll find it goes up very quickly as you change frequency. And one of the nice things about the Moxon is you get this pretty stable performance across the band. So overall, some of the real advantages to this antenna, it's just not a fussy antenna. You get reliable, consistent performance in a lot of different situations. As was mentioned before, you can use it either horizontal or vertical. Usually on HF, people will run them horizontal, but for most of our stuff on VHF and UHF, we run them vertical. Pretty minor performance differences. It has this nice 50 ohm impedance, and that becomes stable at just a little over a half wavelength off the ground. So on a 2-meter antenna, that means the performance of this antenna starts to stabilize at 1 meter off the ground. Now, I'm not suggesting you should run the antenna at 1 meter off the ground. Antennas always work better if you can get them up in the air. But one of the nice things about the Moxon is you don't have to put it 50 feet up in the air in order to get decent performance out of it. It just seems to be so stable. And the radiation angles off of it, if you're familiar with this, if you do HF work, you know, some antennas can end up with these weird takeoff angles, and they end up radiating quite high into the sky. You don't tend to get a lot of problems with that with these Moxon antennas. Good stable elevation angles for the takeoff. Now, as we said, there's always trade-offs and always a few caveats and always a few things you have to consider. One of them is a Moxon really is a single band antenna. Okay, multi-banding a Moxon is a really painful undertaking. Some folks have tried it and you just get some rather strange results. You're better off to deploy different Moxons for each band than really to try to multi-band one of these antennas. It's not a high forward gain antenna, and I'm going to expand on this point a little bit. Now, CBIC advises in some of his material, you don't always need a ton of forward gain. And as hams, we tend to get a little obsessed with that number. Maybe we've been marketed to a little too much. But you don't always need 10 dBi forward gain. In a lot of cases, 6 dBi is lots, and that will clear up the signal and make things work okay for you. Keep in mind, you never get something for nothing. You can build antennas that have really high forward gain. And if you're going to be doing weak signal work or moon bounce or something kind of exotic, you probably need that high forward gain, but you're going to have to trade off something else for it. So for example, antennas that have really high forward gain tend to be physically large, kind of complex antennas. They tend to be a lot more finicky. You've got to get them high enough up in the air. You've got to get them away from nearby objects. They may have a tighter SWR curve, other things like that. You always have to trade something off. So if you want an antenna with a whole lot of forward gain, think about what you're trading off for it. And one of the things that CBIC really liked about the Moxon antenna, it just has a nice balance. You get some forward gain, but you get a bunch of these other advantages as well. A couple of construction concerns, and Ian's going to talk more about this in the construction section, where the elements are bent, those 90-degree bends, that needs to be done correctly, and the gaps between those ends where they're pointed in towards each other, those are super critical. Ian will cover more about that in a few minutes. So overall, this is just a really good antenna for portable use. If you've done much portable use, if you've gone out to support service events, that kind of thing, you realize you have to adapt on the fly to your situation. There's a lot of things you don't control out there, and it's nice to have something that behaves in a stable way and isn't terribly affected by that. So these antennas, they're relatively small, they're sturdy, they're quite easy to transport, set up, and take down. I mean, anything can be broken if you pry on it hard enough, but these are fairly sturdy antennas. They're quite adaptable. Lots of different things you can use them for. Event support, SOTA, people are using them for satellite work. I actually did come across an article. One guy's using it for NVIS, near vertical incident skywave, where you point the energy straight up in the air and then kind of bounces down around you. So lots of different applications that you can use this antenna for. It's quite robust in its deployment. As I said, it's not terribly fussy about how high off the ground you put it. In my experiments with it, if you can keep it a meter or two away from other objects, its performance tends to stabilize. So you don't have to put it, 50 feet away from anything. It's not fussy in the weather. If it gets wet or snowy or something like that, the SWR doesn't suddenly take off to the moon or anything. So it's quite robust. A lot of our applications, a lot of times if you're doing service events or other things like that, we only use one band at a time anyhow. So that mono band restriction, I call it a restriction, but monoband limitation with these antennas is probably not such a big deal. It has a really good RF pattern for venue coverage. If you're taking it out to support an event, If you're set up in a location where the event's taking place, kind of all on one side of you, you don't have to go out and keep adjusting the direction of this antenna. That wide forward lobe will cover quite a large area. And it's also nice out in the mountains where you get that path refraction that happens during the day. The sun comes up and heats up the side of the hills and makes those warm air pockets out there that will refract your repeater signals and stuff around. These Moxon antennas tend to be a little less sensitive to that problem if the path suddenly moves over 10 degrees or something. And that really deep rear null is great for reducing interfering signals. It's surprising how much RF is out there, even when you're way out in the mountains. So it's nice to be able to null that out if it's causing you interference. All right, at this point, Ian's going to talk about actually using these things in the field.
Thanks. That's a great introduction to the antenna, Gary. I appreciate it. I do probably most of my operating is portable. I do a lot of summits on the air SOTA, and the picture here is my first Moxon that I ever built about 10 years ago. It's built for the 6-meter band, and I'm up on Nose Hill. And just in case it looks like an awful lot of equipment, everything that you can see there came in that yellow rucksack leaning up against the rock. And in fact, I've improved my kit quite a bit since then. The Moxon is a very old-fashioned construction. It's built out of PVC electrical conduit that you can just buy down at Home Depot. And I'd like to say it's plumber's delight, but I guess it's electrician's delight. And I hope that if you peer at that framework up there, you can see the wire that defines the Moxon rectangle going around the outside edges. And the feed point is that, I don't know, are you able to point at some of these things, Gary? That might
Sure. Yep.
help people there. Yeah, the feed point is that center, the horn there that's sticking out, and that's the direction that the antenna is radiating its maximum energy, is up there, right? I found the antenna worked okay electrically. I used it on a few VHF contests and got some single sideband contacts on 4 watts from some mountaintops into the Cara website, and gave them a few points on a VHF contest. But the problems that I found, the construction was not adjustable. So this being my first Moxon, I really had no feel for how critical the different lengths were of the reflector, the gap between the ends of it, and I really couldn't adjust them on using this particular frame. You built it, and that was what you got. And everything, it was fiddly to assemble. There's sort of, I don't know, 6, 8 pieces. And so you had to spend some time there putting it all together. It's not glued together, it's just a push fit. And so it was quite fiddly to assemble. And so I didn't, sorry, go ahead.
Sorry to interrupt. I'm just looking at the antenna and I don't see any resemblance to the diagram that Gary showed before.
Oh, okay. Gary, can you run the cursor around the wire there? Okay,
Yeah.
that's the gap just about where it is now. Okay, and then the driven element, the 2 gaps on either side, and then the driven element comes forward, and that's the feed point in the center. Okay, and then there's a wire around the back that's the reflector.
It might be a bit hard to see. I have to look carefully. You can see there's a wire here, but you have to look really carefully against the blue sky.
I think the description, though, would be that what you're looking at, what you can see there is the frame that holds the wires in the air, but the wires, which are the actual elements, are almost invisible. So you have to imagine where they are, right?
Correct. The next picture probably will be a little better if they want to move on to that one. Okay, the next one that I built was for 10 meters. And you can see that the construction is completely different. The spreaders are these tent poles, fiberglass tent poles, And can you run the cursor around the wire there, starting at the feed point? There's the feed point with the coax hanging down from it, and then the two driven elements come along, okay, along like that, and there's the gap. Just yeah, okay, you run in and you'll see the gaps in there, and then there's the reflector that runs out around the back side of the thing. And the nice thing about this, from my point of view, was that because the tent poles are so flexible and they're curved up, keeping the wire under tension, it was so easy to adjust. You could adjust the lengths of the gap. You could adjust the dimensions of the reflector or whatever. And so I was able to work with this and get a feel to discover that of all of the the dimensions in the Moxon antenna, the only one that was really critical was the gap, which Gary mentioned when he was talking about it. You could actually get away with you know, the wire lengths on the driven elements and stuff like that. If they were an inch out, that was not a really big deal. So this was very helpful discovery to me. And here's the next element.
The gap is just a piece of insulator?
Yes, that's correct. Yep,
Certain
that's
length of plastic insulator? Okay. Yes.
Yep, that's exactly what it is. So it makes a continuous wire rectangle loop, right? But it has the electrically, it's not a loop. It's physically a loop, but it's not electrically a loop.
Yes.
Okay, can you show the next slide there? Yeah, okay. This is looking up, and again, you can see the hub. The pole is about 3 meters high, and then the tent poles curve up probably about another 0.7 meter. So that puts the antenna about 0.4 of a wavelength off the ground at 10 meters. And the only trick on this was you had to be fairly careful making the wooden hub, that you needed a tight fit. And the key thing turned out to be a drill press is very useful for making this stuff. You drill it just about the right size, give it a coat of polyurethane varnish, which stabilizes the wood, and then you can re-drill them, or you can actually tap the wood and put a bolt in to hold things and stuff like that. So it's turned out to be a really useful construction technique that I've used again. You can just see over my shoulder on the top left there, you can see the gap. If you follow the wire along, and then, yeah, there's the gap. There's the insulator that forms the electrical gap between the driven elements and the reflector in the background. That's all I've done on the HF side for Moxons, because they start to get to be really big and unwieldy if you start going to the longer wavelengths than HF. So the next slide basically shows where I started looking at the 2 meter stuff. And this was my idea. I thought it would be neat to take a Moxon out onto the Powder Face Trail with doing public service event at one of the rallies, and I knew there were issues with multiple route paths and stuff, and I thought the Moxon might fix this. So it's built from 1/4-inch tubing, and the pole that's holding it up is a painter's pole that I happen to have lying around in my garage, and it's supported by a 2x4 across the roof rack that I've just put on by some bungee cords. So putting this all together, it's literally 5 minutes or so to put it in. The direction that the antenna is radiating at the moment is to the left. So, and it's vertically polarized. Okay, if that helps you figure out that. What I did when I first got there was, it was very easy to just turn the painter's pole around and so rotate the Moxon. And I'd listen to RYC and coming in loud and clear, and then I'd watch the signal on my radio, and all of a sudden it would just turn and it would just drop right down to the bottom. It would just go right off the bottom of the scale, and the FM would just disappear. And then I would just turn the Moxon 180 degrees, and I ran the whole day with the Moxon. I turned the power down to 10 watts, and I didn't have any problems communicating through to RYC for the whole day.
Ian,
Yeah.
just to clarify, on that picture, the driven element is actually the one side on the left.
That's correct.
The
That's
other
the driven
side,
element. Yep.
the backwards C is the reflector that's pointing it, again, reflecting it back to the left.
Yep, that's got it. And in fact, I have a close-up on the next slide, which is me putting it, putting the Moxon onto the painter's pole, and the red there is heat shrinkable tubing that I've used to stabilize the gap. Okay, so and the other thing I would mention about this is I'm gaily waving this antenna around, and if it was a Yagi, I would have been quite concerned about poking myself in the face or the eye with the wires or the elements on a Yagi. But a nice feature of the Moxon is that I actually was feeling quite safe that I wasn't going to damage myself, if not the antenna, by just handling it around like that. So that's definitely a good feature of the Moxon. The poor features of this particular construction, which was my first 2-meter Moxon, you can see that it's not adjustable. You can see that I drilled through the PVC boom, and that's where the reflector is. So it's quite difficult to adjust the gap on that, and because you can't move the two elements backwards and forwards from each other. And it was also hard to solder the coax in, because the driven elements there are right inside the PVC boom. So I was there with a 60-watt soldering iron, shoving them down through the end of the plastic tube, trying to solder on the coax. But what I got out of this construction, there were two good features. First of all, the PVC was a good material for the boom, and for just using it in the element. So that was nice. But the most important one was what I've labeled here radius corners. And Gary alluded to the fact that when you look at everyone's diagrams of these antennas, they all have very precise measurements and 90-degree bends, and the feeling is that you've got to get the physical dimensions very precise. And I've actually seen Moxons where people have, taken a vise or a hammer and beaten the tubing flat so they can bend it over in the vise, and it, you're not sure that you're getting things as they should be. Well, anyway, my son-in-law is a plumber, and I explained to him some of my difficulties that I was having constructing these things accurately. And he sort of looked at me down his nose, disappeared to the garage, and came back with a tubing bender and instructions on where to find a video on how to use this thing properly. And can I get the next slide here, Gary? So it just came out beautifully, and it became so simple to take a piece of copper tubing, just using a metal rule going along, putting the measurements straight off CBIC's diagrams onto the tubing, and using a proper tubing piping bender, and bend it around. And I made the Moxons for 2 meters, of course. This one's 70 centimeters, and I also made a 220-meter one as well. And this particular Moxon, I actually dialed down the power on my handheld there to half a watt, 500 milliwatts. And I was in the basement of my house up in northwest Calgary, and the first time I keyed up my handheld, I was amazed to discover I'd chunked the 440 repeater in downtown Calgary on half a watt from the basement. Anyway, I was really very pleased with how this particular antenna came out. And it has another key thing here, and that you'll see that the tubing does not go through the PVC boom. It's actually on a U-clamp, which is a device that you buy in Home Depot for mounting PVC in your basement or whatever. And so the important point is that you can slide the U-clamps up and down and adjust the gap, which is so critical. Okay, so having got to this stage here, I wanted to go into and just show you how I would run through and make a 2-meter antenna. If you can show the next slide, please. Okay, so go down to Home Depot, buy your 1/4-inch tubing, straighten it all out. The tubing bender at the bottom, it's I got that one. I finally gave my son-in-law back his rather nice tubing bender because he wanted it for work. So I went down to Canadian Tire, and I think that was $35 at Canadian Tire. And as I say, it's very easy. You can see on the tubing, you can see a little black mark on the corners of the tubing, which is just where I've gone through and measured up the dimensions of it, put it into the tubing bender and bend them. And it's literally a few minutes work to make these things. And I mean, you could probably, I was making them 3 at a time, and you'll see why later on. I was making 3. The top one is the reflector element, and the bottom one is the driven element. And you can see in the middle, just for construction's help, I've actually epoxy glued the 2 driven elements onto actually a lollipop stick or a popsicle stick, just to hold them for the actual construction phase as well. So. And then the next slide shows how they get mounted. This is the front end of the boom. So these are the 2 driven elements. This is the point where the coax will attach. The U-clamp is glued onto the boom, so it's fixed, and then just zip ties to hold the whole thing together. And the next slide will show where you turn it over, and you can see the coax coming up through the center of the boom. And then, as Gary mentioned, these things are 50 ohms impedance, and you don't need any matching devices at all. So the coax is just soldered right onto the driven elements. Okay. You assemble everything, loose assemble it, but before you put on the clamps on the gap, you go outside and with your SWR meter, and you measure it up, and you slide the reflector element backwards and forwards to minimize the SWR, and that turns out to be the critical measurement, or the critical element that you have to adjust on these things. And then when you know what that separation is for the gap, then you come in and you glue that rear U-clamp onto the boom, and use the cable ties here to clamp the size of the gap. And then the last one shows the finished product here. Yep, there we go. So for the coax, I just use, what I'll do is buy a long patch cord and cut it in half. So I've got two pieces of coax with a fitting already on the end of it, so that I can use that to attach to the Moxon.
Ian,
So,
on a previous slide you showed, it looked like a matching element or a coil of coax right there.
Yeah. I have to say that the jury is still out on this. When I've looked through the Moxons, every single Moxon I've ever seen has a coil like this just by the feed point that is touted as a common mode choke. And I put them in on the first ones that I made, just because everybody else had done it. And I thought about this, and I thought, well, to my feeling, if you're going to have a common mode choke, the common mode choke should be at the radio, not at the antenna, because if you're going to get currents induced on the outside of your coax, you want to have that length as small as possible. So you want the choke close to the radio. And so I decided I would try making the antennas without the this common the choke, and I haven't seen any negative effects on it as yet. So I've just stopped doing it for the moment. It would be easy enough to put them on if they turned out to be necessary, but as I say, I haven't actually found any need for them.
Going back to the earlier slide where we saw the lobe of the power going one way and being deaf on the other side, I'm having a hard time visualizing this when the Moxon is vertical. I can see it when it's horizontal, but how does that work when it's vertical?
Well, as Gary said, the patterns that are shown for the elevation in when you're looking at the both of them as azimuth pictures. So both of them you're looking down from the top, and the difference between the vertical and the horizontal polarization is actually very small. And that's one of the reasons, actually, that you can use the Moxon for satellite work, because you set it so that it's pointing straight up in the air, and as the satellite comes over, it tracks across that broad lobe in the front as it goes over the top. Yeah.
Okay, so when it's vertical, how do you know which side is your lobe going?
The
Like I'm sticking it up vertical. Is it
yes.
going south or east or west?
It's going okay, I'm trying to work it. It's going along the direction of the boom is the way it's going. And there's a slightly different pattern in the plane of the so-called the apparent loop, as opposed to at right angles to the loop. But think of it more as a cone going out of in the direction of the boom.
Okay.
So Ian, I think that Marshall has the impression that you're holding the antenna like flat, like it's pointing vertically, but that if you go to another previous slide where you're showing the antenna, it's actually horizontal, right? Like in some of your
well, you can go through a couple and go another next slide.
So it's like broadside to the that vertical thing. I mean,
yeah.
Do you want?
Yep, here. This one it's vertically polarized, and the maximum radiation that's being transmitted is directly along that beam to the left and slightly down.
Okay. So the reflector is at the back and the director is on the left, and it's going. Yes.
Yeah, the driven element's on the left and the reflector is on the right.
Okay, so the driven element is never on top of I mean, you don't flip it 90 degree up, then that won't work. Yes. Okay.
Well, if you were doing a satellite, you could turn it so the boom went straight up, but sorry, I shouldn't have mentioned that. Yeah, sure.
I think I understand now. Thank you. Yeah.
Okay.
I think the confusion was when your picture with the handheld and your 70 centimeter, it's pointing up in terms of you've got a picture that's showing the two together, but
okay.
But you can see the arrow on the felt pen there shows the direction that you would point the antenna for your reception, right?
Exactly. You point that boom and in the direction of the arrows at who you want to talk to.
Yeah, so unless you're talking to the moon, this will be flipped 90 degree to the right or 90 degree to the left normally.
Yes, or straight away. Yeah. Right.
Okay.
Yep, exactly.
Okay.
How critical was that gap Gary was mentioning? Is it like millimeters, or can you have a little bit of?
I was adjusting it to better than 0.5 of a centimeter. So, like I'd put it in, so I'd measure 7 centimeters, say, and then 7.5 centimeters, and maybe interpolate. So if that gives an idea.
And the reflector is slightly longer overall if you just held the two pieces of pipe beside each other before they're bent.
Yes, that's correct.
This one, yeah.
Yeah, in fact, I think the next slide, if you keep going on the slides, one more. Yep, there we go. That's what you need to know to be able to build the Moxons. So you remember I said you just get your tubing. So for the 2 meter Moxon, the driven element is 2 pieces that are just about 18 inches. Okay, so that makes up 36 inches total length, and the reflector is 1 piece that's 40 inches. Okay, so if that, and down you'll see the same thing for the 220 megahertz one. It's just under just under 24 inches compared to 26.2. And then for the 70 centimeter one, you can see it's 11 inches as opposed to 12 and a half.
Does it work if you flatten that bend and just?
Yeah, it does, but then you get back into you know, that, I mean, I have to say it looked pretty ugly. But yes, people have done them by doing exactly that, taking the tubing and just squeezing it flat in a vise and then bending it that way.
Can you use heliax instead of copper plumbing?
Sorry, can you use what?
Heliax?
Yeah, I guess I have very little to do with heliax, and being most of this being portable, you know, carrying it in a rucksack and stuff, I've tended to shy away from it and to because most of the coax is very short. It's probably less than 2 meters long.
Just that I have a bunch of
And
spare pieces of heliax that's already copper that you can bend.
okay. Okay. Might be a better idea for a mobile setup, perhaps. Okay.
Is the gap purely empirical, or you have rough measurements before you adjust it?
We have, if you look at Siebig's papers, he gives you all the dimensions, including the dimension of the gap. There's one of his papers, he talks about the effects of changing the diameter of the wire or the tubing, and it changes things differently. Some of the pieces get longer and the gap gets smaller, or vice versa on it. So it's not a simple ratio when you change the frequency on it, but Siebig gives some guidance on that. As Gary said, he's provides amazingly good stuff, reliable and good stuff.
Okay.
Okay, I think that if we go to the next slide, Gary, that'll be your intro to you know, when you can make these Moxons for so easily and quickly and cheaply. Why not make 3 of them? So, and Gary's going to tell us why.
So, yeah, Ian gave me a Moxon there last year, and it got damaged in that windstorm we had. So I had to get him to help me get that fixed. And in the process, we got talking about what other things can you do with these Moxons, and we came up with the idea of 3 Moxons on a pole. And what could you do with something like this? So sometimes when you're doing things like service events, if you're running, say, a net control or ops center, or you're, say, a control point or something, you don't really have time to be out swinging your antenna around. And if the RF pattern changes during the day, as sometimes happens out on Powder Face Trail, you just don't want to be spending your time doing that. So we came up with the idea of, well, what if we put more than one of these up on a pole and you could switch amongst them? And so if the pattern switches during the day, you just reach over to your switch and go click. And it turns out this actually has been working pretty good. So what we have here, this is we were out testing just a few weeks ago. This is my truck here. What I have is one of those lightweight metal telescoping masts. Now, we didn't extend it all the way this day. I think we only extended one of the sections out of it, so it'll go up, you know, 3 or 4 meters higher. But you can see we've only got it the antennas a couple meters off the truck. And yeah, the antennas worked quite well. So what we have here, we have this this metal telescoping pole. I built a call it a sort of an interface board here that allows me to attach the extending mast to a fiberglass pole. Now, the Moxon wouldn't be terribly upset if you did have a metal pole back in behind the antennas, but things always work better if you minimize the metal near an antenna. So we use the fiberglass poles. You can get these from Princess Auto. They're fairly cheap there. Only a few dollars for one of these things. And here's this interface board that connects the telescoping metal pole to the fiberglass pole. Ian made one of these hubs, like you saw in one of the earlier pictures. So he made another one of these hubs, and the booms, the PVC booms, fit into the hub. Then you have the copper tubing antennas, and you can see here there's separate coax feed lines. And this board, I put a few clips on it here just to keep the coaxes from getting tangled up when you're up in the air there. So this is what we were out testing there just a few weeks ago. So yes, 3 Moxons on a pole. I like that. Each of them is oriented about 128 degrees apart in the horizontal plane. That way you get a nice, smooth, coverage of the 360-degree radius. As I mentioned, each one does have to be fed by its own coax line. You can't, as far as I know, I've never seen anybody co-phase these things or anything like that. They all have to be fed with their own coax line. So you need to select one at a time. Only one of those antennas is active at any time. What this allows you to do, though, is use a switch to quickly direct that forward lobe and select whatever direction is going to give you an optimal RF path at the time. And that might be picking the direction that uses the rear null to tame an interfering signal, or something that gives you the best gain in a particular direction. A nice thing for portable use, you don't need a rotor with this, and you really don't need to be out manually rotating the mast during the day. So you can sit inside the truck where it's warm, and if the signal moves around, you just reach up and go click with your switch. To use these short booms, the switch, you have to get a switch that grounds or shorts the unused antennas. They're close enough at that point that they will start to resonate on you. So the unused antennas will start to resonate, and that'll distort your RF field. So you need a switch that shorts the two sides of the coax and prevent that problem. Quick schematic of what we did. So you have your transceiver. You run a coax line to the switch, and then each of the output ports on the switch goes to a different one of the antennas. So if you were switched to using Moxon 1, then the switch would ground out Moxon 2 and 3. And if you were using 2, then it would ground out 1 and 3, and so on. We were using a Daiwa CS401 switch. It will properly ground out the unused lines. So one of the questions comes up, why 3? Why did we decide on 3? Why not 2? Or why not 4? Well, 2 will actually work. In one of CBIC's articles, he discusses doing this, and it will work. In fact, you don't even necessarily need the switch in that case. The antennas will behave quite nicely back to back. But it does limit your ability to point those rear nulls where you want them and reduce interference. So why not go up to 4? Well, 4 does provide you with a little more selectivity in terms of pointing those forward nulls and stuff, but you get to a point, the cost and the complexity, as well as the weight, if you're using a lightweight mast, the weight and the wind load, and it's not like wind is ever a problem in Alberta. The wind load starts to become enough that you have to do extra things to stabilize your mast. So 3 just seemed to be a really good balance, a really good trade-off. You really don't have any substantially weak azimuth coverage with 3. And it's a parsimonious deployment. There's your word for the week. Just means using the least complex thing that will get you the results that you need. So quickly, this is taken from one of CBIC's articles where he discusses putting them back to back. And you can see the pattern is pretty good. it would probably work quite adequately. And if you were building an HF antenna, this is probably adequate for a lot of purposes. But you can see that the kind of off to the 90 degrees here at the 90 and 270 points on the azimuth. If you had a signal right there, or you had an interfering signal coming in there, it would limit your ability to really manage that. So I couldn't find an example of one of CBIC's really nice plots out of the EasyNet program. So this is my best attempt to do it with some mediocre drafting skills and a limited tool. However, this is roughly what the RF pattern looks like off of the triad. And you can see you've got a little more control over where you point the forward lobe and the rear null. And it seems to be a good balance. This seems to be good enough. So far, our test results say this works pretty well. It's probably my limitation in the tool and again, my limited drafting skills. I don't think these points would be as shallow as what you're seeing here. I just wasn't able to make, with the tool I was using, I wasn't able to make this lobe come out quite far enough. So I don't think you'd take this much of a hit at these 3 points. And yes, if you were to build 2 back-to-back Moxons, it looks really nice. Like I say, the complexity of putting it together, it's just not good bang for the buck. You're really not getting a lot of value for doing that. The other thing I'll leave for a thought exercise, if you have 3 Moxons, you have 3 different antennas, and you're cabling them up to the switch quickly because it's minus 30 degrees outside and you're at a winter rally. 3 Moxons, it doesn't matter how you cable them to the switch. The switch behaves intuitively. As you turn the switch, you'll be going either clockwise or counterclockwise around the antenna. But 4 of them, you have to think about how you cable up the switch, or it behaves counterintuitively. And 1 to 2 could be going north to south, and 3 to 4 could be going east to west. And it's just not intuitive if you end up trying to switch amongst them during the day to find a better path. So 3 is just a nice, it's just a nice number, and it just works out well. 4 will work. It just adds complexity to things in how you set it up. So with that, I think we've come to the end of our main presentation. Any other questions or comments at this time?
Have you had a chance to compare in the field, like an Arrow Yagi antenna on 2 meters with a Moxon, and just look at signals that way, or any other antenna for that matter?
We didn't take any out in our tests so far. I don't know. Have you ever tried that out on a SOTA, Ian?
I've not tried a direct comparison between the two, but I've used the different antennas at different, on different expeditions. I think you'd probably see more effect looking at 70 centimeters than you would at 2 meters. And I know that when we've been using 70 centimeter Yagis, you have to aim pretty accurately to make the communication channel work. One person lines it up as well as he can, and then the other person lines it up, and then the first person has to have a second go at it. And it can actually be quite fiddly to use 2 70 centimeter Yagis to get a point-to-point communications.
Have you had?
So I think yeah. Sorry, say again, Jerry.
Sorry, I'm just wondering, like, if you had an experience where you just used your HT with the rubber ducky versus a Moxon.
Yes, I have done that, and the Moxon definitely works a lot better. That's for sure.
I think there was one occasion, Ian, when you and I were on the same hill at the same time on 2 meters, you with a Moxon and me with an Arrow. And I feel terrible right now. We never tried to do anything to do like a quantified comparison, looking at SNRs, or even an ear test of trading antennas and sticking the headphones on. Next time we should do that.
Sure, there's all sorts of things we can try on these. That's for sure. I mean, one of the things that I thought might be one of the more useful things to do is to just get a list of all of the repeaters that we might be using at public service events, and going out and doing a comparison between whether can we hit all the repeaters with the Moxon triad, or can we hit them with just an Omni whip and stuff like that, and just see which ones provide the more reliable communications.
One of our next steps is to take this out probably to Powder Face Trail or some other obscure location and see what kind of additional results. So maybe we'll have a follow-up presentation there for you, Jerry, with some additional detail on field testing results.
Is there a way to do whisper with these antennas and compare it numerically?
Interesting you should mention that, Jerry, because we have actually done some whisper tests. We set up the 2-meter whisper, and you can receive it on the trail, and of course you get a signal to noise ratio out of it, so you can actually see what quantitatively how an improvement, because that's the name of the game, is improving the signal to noise over just getting a stronger signal.
And using less power.
That too. Yep.
Well, that's really great to see. People are still experimenting, learning, trying new things. That's ham radio.
Would it work with coat hanger instead of copper? The metal coat hanger.
I think what you'd find is it would not have the bandwidth.
I mentioned that you'd have to yeah, that's right. You'd have to adjust the dimensions for the to take into account the different diameter.
Usually the greater the diameter of the pipe, the greater the bandwidth to a certain limit.
Yeah, I forget. There's, as Ian was saying in one of CBIC's articles, he deals with that specifically. And with this antenna, because of the electric coupling between those ends where the reflector and the driven element come together, you kind of end up having to make a number of dimension changes to the antenna. You can't always just use the same dimensions if you change the thickness of the conductor. But there are Moxon antenna calculators out there. You can look them up. They're on the web, and it will ask you for these different dimensions, and like what frequency you want to use and what kind of conductor you're using for the antenna elements. Because different sizes of wire, even different sizes of wire, you've got to change that gap. It's fairly critical, but it will give you the measurements for it. And I don't know. You've done more building than I have, Ian. Do you find the measurements that you're getting off of the online material to be fairly reliable, or do you have to adjust them more?
Well, I really only been doing the adjustments since I went to the tubing and thought of using these U-clamps so that you could adjust it. The previous ones that I made, they worked, but I'm not sure that how well. I mean, my instrumentation for measuring SWRs and stuff like that has got better over the years. So it definitely is really nice to have the ability to adjust the gap by sliding the reflector backwards and forwards.
Is there, have you run into anything in CBIC's papers on adding a director onto the front of one of these things? It just seems like a natural, when you're looking at Yagis and whatever and comparing, you've got a reflector here and a driven element. I'm just wondering if there's some way of adding something a little bit shorter in front with a gap and getting even better directionality.
People have tried, but I don't think any of the experiments have been particularly successful. There is actually a design by a German guy which does give you a dual band antenna, and it's a Moxon on 2 meters, and he puts in just some straight elements for 70 centimeters, and they're parasitic, and so it is actually a 2-band antenna, but it's a Moxon on 2 meters, and I'm not quite sure what you would describe it as. It's more like a Yagi on 70 centimeters. But that's the only one that I've really seen that's been successful with multiple elements, beyond the 2.
It's easy enough to bend them towards each other and use an insulator in between. But what do you do? How do you mount the third one if you have a director?
The only thing I remember seeing is something like Ian is mentioning, where someone has tried to put another director out here. Keep in mind that the big advantages of this, especially for portable use, like Ian was saying, you don't have the poke in the eye problem so much with these antennas. And you can throw these things in your trunk or in the back of your truck and just drive on. And they're pretty robust. And unless you drop a 100-pound tool case on them, they don't get damaged that easily. When you start adding other things, especially Yagi-like elements onto it, you kind of give up some of those advantages, and probably only getting small improvements. If you're going to use it for a base antenna at home and just set it up in your backyard, maybe it's worth the extra fuss factor. But for portable use, the nice thing about these is just that minimal fuss factor.
Very good. It looks like it'd be very good for direction finding and for fox hunting as well.
Yeah, as I mentioned, when I was out on Powder Face Trail, I was really impressed with the depth and sharpness of the null on the back of the antenna. So yeah, I haven't done a lot of fox hunting, but that did occur to me.
Very, very good work, and we look forward to seeing what else you guys are coming up with. Other questions, comments?
You said you have to ground 2 of them if otherwise it doesn't work properly. How do you ground the coax cable?
So the switch that we used, some switches do this. It's just built into the switch. I'm sorry, I didn't take a picture of the switch. I guess I should have thought of that. The actual switch, if you were to Google Daiwa CS401, you see a picture of the switch we use. Okay. And that switch grounds all of the unused ports. So if you turn that switch to coax number 1, inside the switch, it actually shorts and grounds the other lines.
Oh, so the inside conductor of the coax is short with the shield of the coax?
Yeah, so it's all grounded. Really, ideally, you'd ground the switch itself. There's a spot on the switch where you can ground the switch itself. So everything would be attached to ground.
Okay. Okay.
The idea is that these antennas are fairly close together. We've used fairly short booms. So you're well within the near field on the antenna. And if say this was the antenna that you had switched onto, the other 2 are close enough that they would start to resonate, and you make an antenna resonate and it starts to radiate some of that energy back out, and it distorts the field pretty badly. When you ground these things out, they're essentially just null up there. They're not doing anything anymore, and they won't try to resonate and radiate on you.
Okay, so I don't know, maybe stupid question. If you were to nestle another 70 centimeter and Moxon inside the bigger one, and you ground the bigger one, would it work? I mean, I don't know. Is that a stupid question, maybe?
No. People have tried this, and if you read CBIC's page, people have tried that, and it just doesn't seem to work. The antenna on the inside just gets excited like crazy when you do that.
Okay.
So CBIC, part of the reason this works is that, again, say this is the antenna you were using. these other two antennas are in that back null behind the antenna, behind this one. So there's not a ton of RF back in here. It's not a ton of energy. There's only just a little bit. So if you ground these two out, it's enough to just null them out and they just go away.
Oh,
But
but
some,
if you put it inside there, it will have a ton of energy. Yes.
yeah, and it's pretty hard to get rid of that effect. Seebeck's articles, like I say, this guy was just amazing, and his writing is so good, and I really enjoy his articles. The one that's hard to read is the one where he talks about trying to multiband a Moxon. It's just an agonizing article to read because you could see how frustrating it was. He tries several different things, and nothing really works very well.
Okay, thank you. Yeah.
Any other questions or comments for Gary or Ian? Okay, well, thank you both for a wonderful presentation and some great work. And if I had some little memento to give you, I'd give it to you, but we haven't come up with that yet. But I would like to encourage others who are experimenting with things to come forward as well, and more computers, more we can learn. I also would like to show here, if I can. I've got several books on wire antennas. This one here, this is RSGB from the UK. Practical Wire Antennas 2. I don't know where my antenna wires 1 went. This is a classic book, AR wire antennas. It's just reprints from various publications throughout the years. So you get all kinds of good ideas for planning antennas. And then this is a classic from Bill Orr, who's also Silent Key. I think I appreciate Gary's comment about all the silent keys. These were not because of the antennas, but because they did this work so long ago and set so many standards for how to construct things, how to what practical aspects to consider, and so on, that people have continued to quote them for decades afterwards. And so building antennas can be one of the most satisfying or frustrating aspects of the hobby, because you get to play with it in real time. You get to measure things quantitatively, tinker with it, come up with new ideas, see what works. It's very pragmatic and very constructive to try all kinds of different things with antennas. And quite often you'll find that something actually works when you don't expect it to. I was working on, I built an inverted V for 60 meters about 3 years ago, and all the calculator programs and whatever said I had to do it this way, and I had to have a matching network and all this stuff. I just put it out there, and I ran out of space in my yard, and I said, well, let's try it anyway, and it worked great. It just, I put it up and started playing with it. I didn't have to do a whole lot, maybe 3 or 4 hours total of playing around with the lengths and a few other things, and it's been working. And with about 60 watts or less, I've got almost 60 countries on FT8 on 60 meters with this homemade antenna. So there's a lot you can do, a lot you can play with. I noticed in this month's QST magazine, I was looking at it online today, it just came out. There was a commercial product for a quarter wave ground plane 2-meter antenna, which looked for all intents and purposes like the classic SO239, where you take a coat hanger or 2 coat hangers and you make little loops on the ends of straight pieces that you cut off the coat hangers, 19, I think, inches each piece, and then another piece you stick in the middle of the SO239. You've got a great quarter wave ground plane for 2 meters. This one was a little more professionally made, but they want $85 for it. So you can make this out of stuff you've got in the shack already.